You're welcome at Medical Sciences by Naphtali Muhumuza, and in today's session, we want to discuss about calibration curve. We want to see how can we prepare a calibration curve using hemoglobin cyanide standard, which is part of the Drabukins, which we use for HB determination. But in this video, we want to look at this. We have already diluted 1 in 201. So to get this standard, we have already diluted. We're using dilution factor. As we know in Drabukins, we use the dilution factor of 1 in 201. So this standard which we are going to use, it is already diluted. So it is ready to use. But we want to use a single standard. And for example, in our discussion today, we are going to use HICN standard or hemoglobin cyanide standard of, we want to use the one of 52.5%. What we normally call it milligram percent or milligrams per deciliter. So if we are provided with this ready to use, and because cyanide hemoglobin is stable, these standards are already on the market and can be stored for even 2 years. So whenever you are in the laboratory and you want to prepare a calibration curve to use to determine HB by Drabukins method, or what we call cyanide hemoglobin method, they are available. So we can always use them to calibrate our colorimeters so that we can develop the curve which we can use to develop the HB concentrations versus the absorbances. So we want to use 52.5 milligrams percent as our ready to use standard. And this standard is already in the fridge. So the first time you do when you want to start calibration, you first bring them to room temperature for them to warm. You first leave them to warm. And as we begin the process, we remind you to subscribe, share your comments, and like the video for more growth. So the first method or the first procedure we do in this type of calibration curve preparation, we first convert this cyanide hemoglobin standard to its original HB value. So the first step is to convert the HICN standard to its hemoglobin value. Because as I told you that this standard, we used a known hemoglobin, the preparer used a known hemoglobin to get this standard. So we have to first take it back, whereby we have to convert, we are converting 52.5 milligrams percent of HICN standard to the HB value. So what we do is that 52.5 milligrams percent means 52.5 milligrams per deciliter. Because percent means per 100 mils, and 100 mils is equivalent to 1 deciliter. So that's why we are saying milligrams percent means milligrams per deciliter, which is 100 mils. It means 52.5 milligrams dissolved in 100 mils, and 100 mils means 1 deciliter. So what we are going to do is we are going to convert, we are converting 52.5 milligrams per deciliter to grams per deciliter. Since it is given in the deciliter, we shall maintain the deciliter. Then our role is to convert milligrams to grams. And how do we convert milligrams to grams? We begin with what we have. We know that 1,000 milligrams are equivalent to 1 gram. So what about 52.5 milligrams will give us, we cross multiply, whereby we get 52.5 milligrams times 1 gram. Then we divide by 1,000. Then the milligrams will go with the milligram, and we shall remain with 0.0525 grams. So this one is giving us 0.0525 grams. But remember, these grams are in a deciliter. So this is, so at the long run, we are seeing 52.5 milligrams per deciliter, equivalent to 0.0525 grams per deciliter. So after doing this, we remember we diluted using 1 in 201, but the dilution factor is always 200. So the dilution factor is 200. So to get the original HB value, so HB value is going to be the HISN standard. It is HISN standard in grams per deciliter times the dilution factor, which is 0.0525 times 200, which is the dilution factor, and we get, we can calculate together. If we use the calculator, we are going to see 0.0525 times 200, and we get 10.5. So that one becomes 10.5 grams per deciliter. So this is the HB, this was the original HB value of the blood, which we diluted using 1 part of the blood with 200 parts, 201 part of the drabokins to get this concentration. So after getting the original HB value, which we used to prepare the standard using modified drabokins, this was the first step. The second step, what we are going to do is to calculate the HB values of the, because we want to do serial dilutions at least 5 tubes. So we're going to prepare 5 tubes whereby we shall pipette as follows. But before we pipette, we can prepare now the HB values of different concentrations. Remember, we want to pipette as follows. We pipette as follows. And what we do, but as we are starting to pipette, here we can switch on the calorimeter. You switch on the calorimeter and leave it to warm for 15 minutes. Because these are ready to use, we don't need to intubate. So before we begin pipetting, it is advisable to switch on the calorimeter to be warming as we are pipetting. So what we are going to do, we are going to pipette, we are going to have the drabokins. Here the solution we are going to use to dilute is not distilled water, but we are going to use the drabokins solution, and it will be in mils. We shall also add the HISN standard in mils. We shall also get the concentration of the HB, what we call HB concentration of each tube. Then we shall also get the absorbances. Shall read the absorbances. So this is going to be our table, whereby here we are going to have different tubes, where we are going to have the blank. Then we are going to have tube 1, tube 2, 3, 4, and 5. And after having these tubes, in the blank we are going to put on the drabokins. But before this, we also need the total volume. We can fix here another table for the total volume. And the total volume we need here is 5 mils in mils. So we need total volume of 5 in each tube. We need a total volume of 5 in each tube. So to get the total volume, for the blank, what we are going to do, we are going to put 5 mils and we put 0 mils of the standard. Whereas in tube 1, we can put 4 mils of the Drabukins and 1 mil of the standard. We have to ensure that the total volume is 5. Here, if we put 3, then here we shall get 5 minus 3, which is 2. So that it gives us a total of 5. If we put here 2 of the Drabukins, the standard in this tube 3, these are tubes which we have labeled. Here, if it is 2, here we shall put 3 to make a total of 5. If here we put 1, here we shall put 4. And here, if we don't put anything, here we shall put 5. So this one is going to act as our original concentration without being diluted. So this is our serial dilutions we are making, which we are going to use to develop a calibration curve. So after doing this, remember we don't have concentrations. These are serial dilutions, so we need to calculate the HB concentration. Shall calculate the HB concentration. So, but before we calculate it, after mixing the contents in the tube, after pipetting as follows in each tube, so we mix the contents. We mix the contents in the tube. After mixing, we set the calorimeter. Set the calorimeter. We set the calorimeter at 540 nanometer wavelength. This is the wavelength we are going to use to read the absorbances. After setting it at 540 nanometer wavelength, the next step is to zero. We zero the calorimeter using the blank. After zeroing the calorimeter, we read the absorbances. We read the absorbances of tube 1 up to 5, and we record. We read the absorbances and we record them. After reading the absorbances and recording them, that is, after obtaining the absorbances here, so we shall record them in this absorbances. We shall come and record them. We have obtained them using calorimeter, then we record them. So the next step is to calculate the HB concentration of each tube. So here our next step is to calculate the hemoglobin concentration of tube 1 up to 5. We want to know after diluting, remember the original is 10.5. So we shall find here we have 10.5 already because we never diluted anything. But here we have diluted using Drabukins, so we need to get the concentrations which we have used. So what we do, we come and calculate the HB concentrations, whereby in tube, remember in tube 1 it is 0 because we have not put any Drabukins, it is the blank. Then in tube 2, in tube 1, we have to put 1 mil of the standard, 1 mil of 10.5 grams per deciliter. So we shall get 1 mil, which we have put of the standard, we divide by the total volume. So we get 1 mil in tube 1, which we have put for the standard, we divide by the total volume, we multiply by the HB value, which is 10.5 grams per deciliter. We get its answer. We go to tube 2, and in tube 2, we have put 2 mils out of the 5 total times 10.5 grams per deciliter. In tube 3, the same thing. We have put 3 mils of the standard out of 5 times 10.5 grams per deciliter. Then in tube 4, we have put 4 mils out of 5 times 10.5 grams per deciliter. We shall also obtain its answer. So here we are seeing After diluting the 10.5 grams per deciliter, we get different concentrations, which we are going to calculate. So what we do, we calculate them, whereby 1 divided by 5 times 10.5, we are able to get 2.1. We get 2.1 grams per deciliter. Then we are seeing in tube 2, we have put 2 mils out of 5, then times 10.5, we get 4.2 grams per deciliter. In tube 3, we have put 3 mils of the standard, we divide by the total volume, then we multiply by the original HB, which is 10.5, we get 6.3. Then in tube 4, we have put 4 mils out of the 5 total, then what is the total volume? Then we multiply by the 10.5, we get 8.4 grams per deciliter, grams per deciliter. But we said in tube 5, since it was 5 out of 5 times 10.5 grams per deciliter, we get 5 goes with 5, we remain with 10.5. So these are the HB values we are going to use to come up with the calibration curve against the absorbance. So we are going to see absorbances against the HB concentrations. So after obtaining the absorbances of each tube, and we have also calculated the HB concentrations of each tube, the next step is to plot the graph. So here, after calculating everything, we are going now to come and plot. We get a graph. We obtain a graph paper. Obtain a graph paper and plot. We plot absorbances of each tube. Absorbances of tube 1 up to 5 against their HB concentrations. So we are going to plot the absorbances against HB concentration. After we have plotted the graph, the next step we shall do is to draw the line of best fit. So after plotting the graph, we draw a line of best fit through the points plotted, But this line of best fit should come from the origin, should be from the origin. Origin means 0, should be from 0. And after drawing the line of best fit, through the points, for the colorimeter to be doing well, it should, after plotting, it should give us a straight line. For the colorimeter to be doing well, it should give us a straight line through the points, through the plotted points from the origin. That is what should give us a straight line, but from the origin, which is 0, and we should extrapolate. We extrapolate the straight line up to 20 grams per deciliter. Since HBs of many people, they don't exceed 20 grams per deciliter. So we extrapolate up to 20. Then after extrapolating up to 20, that's when we shall obtain from the graph, from the curve plotted, we can obtain the HB concentrations of different absorbances, on a paper. So these different absorbances of different HB concentrations versus the absorbances are the one we shall pin on the wall and we shall be using for the next 3 months or even 5 months to read our HBs. Remember, in the hospital, people are many and they are busy. You can't be calculating every time using B. Lambert's law. So after preparing the calibration curve, this is the one we use to always determine our HB concentration. Whenever we get absorbances in the hospital, we go to our curve and we compare. And this is how it is drawn. So remember here you recorded different concentrations. This one was 2.1 grams per deciliter. This was 4.2. This was 6.3. This was 8.4. Then you obtain absorbances, which we don't know now because we are not doing a practical, but when you obtain them, you put them there, then you plot the absorbances against the HB concentrations of each tube you plot, as we are going to see. And how do we plot? Here we shall draw a graph. We shall extrapolate the graph from this table. Whereby this graph, you first put a title. And the title of the graph says a graph in capital letters, a graph of hemoglobin concentrations against the graph of absorbances against hemoglobin concentrations. You underline the title, then you obtain the scale of the y and the x-axis, whereby on the y-axis we are going to have absorbances, what we call optical density of each tube. Then on the x-axis we are going to have hemoglobin concentrations in grams per deciliter. This is our calibration curve. And remember HB concentration we have here, this is 0. We shall have 2.0, we can have 4.0, we can have 6.0, we can have 8.0, 10.0, maybe 12. Then from 12 we go to 14, 16, 18, and it should be up to 20. So what we do, if we obtain absorbances on the colorimeter, we come and plot. If this was 2.1, then maybe the absorbance was here. We come on 2.1 here and we plot. We come on, this one was 4.2, we come at this point, we plot. If this was 6.3, it's like at this point, we come and plot vis-a-vis the absorbances. But at this point, we can't assume them because we don't know them. Then we go to tube number 4, it is 8.4. We go where there is 8.4, we plot. Then the last one is 10.5, which is at this point, we come and also plot. Then afterwards, we draw a line of best fit through the origin. And when we draw it, it should be a straight line through all points. So this, after plotting, we draw a line of best fit or a line passing through the plotted lines, and we extrapolate it up to 20. We have to extrapolate it up to 20. So after doing everything, we come up with a straight line of the calibration curve. And this calibration curve, which has passed through the points, is the one that we are saying we shall be using to determine the HB concentrations. So if we have here different concentrations, like this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.5, 0.6, 0.7, 0.8, 0.9, then 1.0. So we shall get our paper whereby we are going to match the absorbance with each HB, whereby what we do, we go on the curve, we get a paper. So where there is 0.1, we extrapolate, we meet the line, we come and read the HB concentration. So if this is the paper, it has the absorbance together with HB concentration. So at 0.1, you come and record, maybe this is, the HB is 1.0. If I get absorbance of 0.2, I come and extrapolate on the curve. I come and read the HB, maybe HB is 2.2 grams per deciliter. Like that. If I get absorbance of 4, I come and extrapolate. Where I meet the curve, I read the HB value. If I get 0.7 as absorbance, I extrapolate in a straight line. Then I read the HB concentration. So if I get absorbance of 0.7, I match it with 10.5. If I get absorbance of 0.9, I meet a curve, I come and read HB, maybe it is 16, I record. So this is what we shall use every time we are working in the lab to determine the HB concentrations of our patient, whereby you just get the absorbance from the colorimeter, you come on your paper which you extracted from the curve, and you use them, you match them with the HB concentrations without using calculator every time by Beer Lamberts. So this is the reason, and whenever you obtain a new colorimeter, the first thing you do is the calibration. And whenever you get a new control, every time you buy a new control, you must develop or prepare a calibration curve for that particular reagent or that particular new colorimeter. So this is what we do to come up, and all machines in the laboratory, they do this, whereby every time we install the machine, we develop the calibration curve, and it is the machine that uses the calibration curve to come up with the values. So for the machine reads the absorbances or the optical density, and it matches with this calibration curve to give you the results. This is what we can discuss today. So we have seen steps is that we first calculate the HB value from the standard. After that, of course, we leave it warm at room temperature. Then we switch on the colorimeter and we leave it warm for 15 minutes. Then we pipette, as we have seen, in 5 tubes. And after pipetting, that is, we are doing serial dilutions. Then we mix the contents, and these are ready to use. You don't need to intubate. What we are doing is just to get serial dilutions to help us to come up with different points. Then after that, we set the colorimeter, we mix the contents, set the colorimeter at 540, you zero the colorimeter, you read the absorbances of each tube from tube 1 to 5, then you record their absorbances in the graph on the table. Then after putting the absorbances, then you calculate different concentrations of HB after making serial dilutions. And that one, then you use the absorbances against the HB to plot, come up with the calibration curve. Then after drawing the calibration curve, you plot the points against their absorbances, HB concentration against their absorbances. You plot them. Then you draw a line, a straight line, through the line from the origin, and it should be a straight line. For you to have done, if you have not done many errors, it should produce a straight line, and this straight line is extrapolated up to 20. Then after doing that, we use this curve to read or to match the absorbances against their HB value, so that whenever we do other subsequent tests, we don't need to apply the Lambert's law. We just read directly from the curve, whereby we develop a paper and we pin it on the wall, where every time we want to read the concentration of each absorbance, we just refer to the paper. Thank you so much for listening. May good Lord bless you.